We're looking at 13.3 right now. We're going to be talking about arithmetic and geometric series, as well as their sums. So previously we talked about sequences, and we're going to be talking a little bit more about series instead of sequences. So, in everyday conversation, sequence and series are kind of interchangeable. But in mathematics, there is a distinct difference between these two, right? So we might have a finite sequence, and that sequence might be, 2, 6, 10, 14, right? It's finite because it's got only 4 terms, right? There's an end to it. It's a sequence. It seems to be arithmetic, right? Because we have an increase of 4 from one number to the next. Now, if we wanted to write that as a series, though, right? If I want to write the series of this finite sequence, well, then what I'm going to have to do is write this as a sum, right? So this is going to be 2 plus 6 plus 10 plus 14. Right? So a series should be considered as the indicated sum of the terms of a sequence. So a series, I'm going to change my color here. Let's go blue. All right, a series is the indicated sum of the terms of a sequence. Sorry if you hear clickety clacks. That's the sound of my dog walking on the ground. Right, so those are finite sequences. What about an infinite sequence, right? An infinite sequence. Well, that could be something like, let's start with 1/2, and then half that, and then half that, etc. Right? We could go on and on and on forever. This is an infinite sequence. Notice it's just number. This is geometric because it's got a constant scale factor from term to term of 1/2. Right? And we could write that as an infinite series. And like we said earlier, that is just the indicated sum of the terms of a sequence. So that's going to be 1/2 plus 1/4 plus 1/8 plus 1/16 plus everything that comes after that. So the only thing is that, if we're thinking about different kinds of sequences and different kinds of series, the sum of any given sequence that is finite, so if I'm talking about finite sequences, the sum is going to be some constant number. However, the sum of an infinite series is not always going to be something that we can find, right? If my infinite series was 2 plus 6 plus 10 plus 14 plus 18, etc., that sum I can never find it. But with this fractional infinite series, and that's the sound of my dog drinking in the background, the sum of this fractional series we'll actually find is equal to 1. So let's define a couple of definitions for series, right? So we've got our explicit definitions, and then we've got the recursive, and this is something that y'all would have looked at yesterday. And remember, an explicit definition gives you a formula for any given term that you're looking at, right? So the series that you may be looking at, well, that's going to be T1, your first term, plus your second term, plus your third term, plus all the way up to that nth term that you're looking at. Now, the recursive definition gives you your initial value and then how to find any value after that based on those initial values. Well, let's put this into practice. Why don't we? Let's find, and I'm gonna actually switch colors here again. Let's because I can. Let's go purple. Purple, how pretty. All right, so let's find the sum. Sorry, I got a little lopsided there. Find the sum of the first 25 items, or first 25 terms of 11 plus 14 plus 17 plus 20 plus ... right? So this is our series. It's infinite, and we want to find the sum of the first 25, okay? So our first step is to find the 25th term. So first I need to find, I'll do it like this, find 25th term. Well, to do this, right, because if I want to be able to find the sum of these, I'm going to need some sort of an equation, some sort of a formula to be able to do this. And the formula that we are going to be using, and I'll put this in orange here, the formula that we're going to be using is S of n, right? So any term that I'm looking for in a series, the sum of any term, is going to be equal to the term that I'm looking at, the numbered term, times the sum of my first plus that nth term divided by 2. Okay, so if I'm going to find the 25th term, I'm going to be looking for T25, right? 25th term. Well, that's going to be T1 plus n minus 1 times d. This is from our previous couple of lessons, right? So that's going to be equal to 11 plus, well, the number of term I'm looking for, 25 minus 1 times d, and now d, remember, that's going to be that constant difference between these terms, right? So that's going to be 3. And I'll do a little bit of this action for us. All right, so this is going to give me my 25th term. This is the equation for arithmetic sequence of finding whichever term you're looking for based on the information that you've been given, right? And this, we see, is equal to 83, right? So the 25th term is 83. If the 25th term is 83 and I know the first term, then I can solve using this right here. Okay, so step 2. Second, I'm going to say, well, then S25, I'll scroll up just a little bit here, is going to be equal to n times T1 plus T25, first term plus my 25th term divided by 2. So n is 25, T1 is 11, T25 is 83, divided by 2. That gives me an answer of 1,175. So that's how I can find the sum of an infinite arithmetic series that has been made finite, right? I made it finite by saying, hey, find the 25th, or find the sum of the first 25 terms. So what we found is this definition here, and this is for finding the sum of arithmetic sequences, right? This is for sum of an arithmetic sequence. Oops, of an arithmetic series, not sequence. Now, what if we want to find the sum of a finite geometric series? The equation that we're going to use for that is the sum of the first n terms. I'm going to put a little, the sum of the first n terms, where r is just our common ratio, and r cannot be equal to 1, right? So whatever we want to find that sum of, right, it's going to be equal to that first term you've got times 1 minus r. Now r, remember, that is your common ratio. And n, that's the number of terms that we're talking about, okay? And we divide that by 1 minus that common ratio, okay? So here's a problem that we get to work through with this. Let's find the sum of the first 10 terms of this series. We got 2 minus 6 plus 18 minus 54 plus et cetera, right? It's very obvious that what we're dealing with here is a geometric series because we have a common factor, right? I've multiplied 2 by, we've times this by negative 3. Then I've multiplied this by, times by negative 3, right? And that's just carrying and carrying and carrying, right? Times negative 3, et cetera. So we can see from this that R is equal to, well, that's negative 3. We can see T1, now that's our first term. What's our first term? Well, our first term is 2. And if we look at this equation, all we need to know is that first term. All we need to know is that first term, which is right here. And we need to know R, which is right here. So let's replace those in so that we can find what S, the sum of the first 10 terms of this series is, right? So that's going to give us 2 times 1 minus R raised to the 10th power. And that is being divided by 1 minus negative 3. For if I was teaching this to like a pre-algebra or algebra class, I would require my students to throw in these parentheses in here. But you guys are smart, and I know that you can see that as a minus of a negative, the subtraction of a negative, so that's just addition. Well, when we plug this into our calculators, which I know you guys will be able to do just fine, we're going to find that the sum, right, if I add all these together for the first 10 terms, turns out to be negative 29,524. Oops, slid a little bit there. And that's the basics of it. So if you guys have any questions, don't hesitate to reach out. And with that, I say goodbye.